Parallel and perpendicular lines. This is the last bit of line stuff we have to talk about. Parallel lines. Two lines are parallel if they have the same slope but different y-intercepts. Visually, parallel lines are never going to intersect. So they have the same slope, which means if I just duplicate this, these two lines are parallel. They could be really close together. They could be really far apart. They have different y-intercepts, but they have a slope that's the same. They increase at the same rate. Okay. We could have vertical parallel lines. Any two lines that are vertical are going to be parallel to one another. So these parallel lines will never intersect because their slope is the same. It's important that they have different y-intercepts because if they don't have different y-intercepts, it's actually not parallel lines, it's the same line, and that's not what we're looking for here. We're looking for different y-intercepts so that they are different lines. Because if you have the same slope and the same y-intercept, you are indeed the same line. So just an example algebraically. Ooh. My iPad has been a little weird today. If we have y equals 2x plus 7, y equals 2x minus 5, these are parallel lines. They have the same slope, 2, and they have different y-intercepts, 7 and negative 5. We could have y equals negative 2/5 x plus 9. You know what? I'm going to pause this. My iPad is acting real weird. I'm going to need to restart it. Give me a second. It'll be 0 seconds for you. All right. I think we might be good. Let's hope. All right. So we have a line in slope-intercept form here, but we could also write another line in the parallel line in point slope form. Okay. So these guys right here are parallel as well. They both have a slope of negative 2/5. It looks a little different because one is in slope intercept and the other is in point slope, but they are still parallel. Okay. So parallel lines have the same slope, different y-intercepts. They'll never intersect. Perpendicular lines. Two lines are perpendicular if they intersect at a right angle. That's a 90-degree angle. Slopes, ooh, this should say slopes. Slopes of perpendicular lines are opposite reciprocals of each other. Let's zoom in on this word, opposite reciprocal. Which I'm going to abbreviate to OR from time to time. Opposite reciprocal is going to be the reciprocal with opposite signs. Reciprocal with an opposite sign. Reciprocal is just flipping a fraction upside down. So for opposite reciprocals, if we have 2/3, the opposite reciprocal of 2/3 would be negative because we change the sign and then flip the fraction. So instead of 2/3, it'd be 3/2. So the opposite reciprocal of 2/3 is negative 3/2. If we have -5, which doesn't appear to be a fraction, it still is. Anything is a fraction if we want it to be. -5 is the same thing as -5 divided by 1. So for the opposite reciprocal, we'll make it positive to change the sign, and then flipping 5 over 1, you get 1 over 5. So the opposite reciprocal of -5 is positive 1 over 5. If we have -1/4, the opposite reciprocal will be positive. And then if you flip 1 over 4, you get 4 over 1, which is just 4. Just going to move these guys down a tiny bit. And you know what? I better not do that because that could mess up the spacing I have on different pages. I'll just leave it alone. Visually, perpendicular lines, once again, they meet at a right angle. So something like this, where there's a right angle. This would be two perpendicular lines because those two lines meet at a right angle. Vertical lines are all perpendicular with horizontal lines. So every vertical line is perpendicular to every horizontal line. I'll make a note of that. For algebraic examples, something like y equals 2/3 x plus 1 and y equals -3/2 x. These are perpendicular lines. They're perpendicular because their slopes, the only thing we care about with perpendicular line, their slopes are opposite reciprocals. They are opposite reciprocals. Something like y plus 2 is equal to -1/7 times x minus 5, and y minus 8 is equal to 7 times x minus 1. These guys right here, these are in point slope form. We don't care what the point is, we just care about the slope. If we look at those slopes, those are indeed opposite reciprocals. They are opposite signs and they are reciprocals of one another. Ooh, that wasn't what I meant to do. Oh man. So here the slopes are -1/7 and 7 over 1, which is just 7. And they are opposite reciprocals. So those two lines are perpendicular. So for a few lines, let's find the slopes of the parallel and perpendicular lines. So for each of these, we'll find a parallel slope and we'll find a perpendicular slope. right? This line is already in y equals mx plus b form. It's already in slope intercept form. So we can easily pick out the slope. The slope is -6. So for parallel lines, they're going to have the same slope. So the slope of the parallel line would be -6. Any parallel line will have slope -6. Any line perpendicular to this line will have the opposite reciprocal as its slope. And the notation we oftentimes use is M perpendicular. So this is a subscript down here. This is a subscript, like an upside down T. You can look at it as kind of like it's forming a right angle. It's like showing you what a right angle is. M with that little symbol down below, that's the perpendicular slope. So the perpendicular slope here, opposite reciprocal, our regular slope was negative, so ours is going to be positive. The reciprocal of 6 is going to be 1/6. All right. The next one is x equals 2. For x equals 2, we need to, this is a special line. This is either a vertical or horizontal line. So we can draw ourselves a small picture over here. X equals 2 is going to be the line where all the x values are 2. So that would be somewhere out here, right? Where this is like 2 on the x-axis. So it's a vertical line. Vertical lines have an undefined slope. If you think about the little car can't drive on this line because it has no slope. So all parallel lines are going to have an undefined slope. In fact, all parallel lines are going to be x equals a number because all the parallel lines are going to be all other vertical lines. For perpendicular, I'd mentioned this before, we're going to be perpendicular to all horizontal lines. So horizontal lines, like this guy right here, they have a slope of 0 because you can drive a car. It's just you're not going up or down. You can drive a car on it though. So the perpendicular slope is 0. And really, you can kind of think of what's happening here as undefined is like kind of like 1/0 here. So you end up with your perpendicular being 0/1, which is just 0. All right. Next example, 8y minus x is equal to -7. We need to rewrite this in y equals mx plus b form to find the slope. So we have 8y minus x is equal to negative 7. We want to get y by itself. I am adding x to both sides. Eight y is equal to x minus 7. To get y by itself, I am dividing both sides by 8. Y is equal to, now we have x divided by 8 minus 7/8. First of all, the 7/8 part doesn't matter at all for us because when we're finding slopes of parallel and perpendicular lines, it doesn't matter what the slope is of the original. But this x over 8 thing might be kind of confusing. So let me, x over 8 is the same thing as 1/8 x, right? These are the same thing because if you multiply 1 over 8 and x is the same as x over 1. So you would multiply those fractions straight across, x over 8. So this really is y equals 1/8 x minus 7/8. So our parallel line, let me go ahead and grab it from here. Our parallel line is going to have the same slope as this line. It's going to have slope 1/8. And our perpendicular line will have opposite reciprocal slope. So the opposite reciprocal will be negative, and then it will be 8 divided by 1 instead of 1 divided by 8, which is just negative 8. Bam, done. So let's use that idea and go a little bit further with it. We're going to take this line here, and we're going to find a parallel line to this, a line that's parallel to this line that passes through the point -7, -5, and a line that's perpendicular to this line that passes through -7, -5. Just like we did above, but with a little bit more work. Sorry, I had to pause the recording there for just a sec. All right, back to where I was. Parallel, perpendicular line going through a particular point. So we need to find the slope of this original line first to go anywhere. So we're going to solve for y, get y by itself. That way we're in y equals mx plus b form. We can figure out the slope. So I'm subtracting x on both sides. We get 2y is equal to negative x minus 9. Divide everything by 2. We end up with y equals negative x divided by 2 is negative 1/2 x minus 9/2. Again, this, I don't even care about this y-intercept. I could get this number wrong and it wouldn't mean that I would get these problems wrong. So we have y equals negative 1/2 x minus 9/2. That means that for the parallel line, lines that are parallel to this line will have slope negative 1/2. And perpendicular lines, lines that are perpendicular to that line, will have slope positive 2 over 1, which is 2. For both of these lines, we're looking at the point -7, -5. So I'm going to be doing this work separately. I will start with parallel. Now that I have the slope, which again, I got from solving for y here, taking the same slope, I have a slope, I have a point. You can do this in one of two ways. You can use point slope form and solve for y, or you can use it, or you could put it in as y equals mx plus b, put the m, the x, and the y in, and solve for b. I'm going to use point slope form on the parallel, and I'll use the slope intercept form for perpendicular. So for point slope form, y minus y1 is equal to m times x minus x1. We have the m, we have the x1, which is -7, and we have the y1, which is -5. So this becomes y minus -5, so plus 5, is equal to m is -1/2, x minus -7, so plus 7. Solving for y, I am distributing. So I have y plus 5 is equal to -1/2 x minus 7/2. Subtracting 5 on both sides. Y is equal to -1/2 x. Let's see, mental math, minus 17/2. That is the parallel line that passes through the point -7, -5. Okay, this is one way of doing it. This is the point slope formula where you plug in your point and your slope, and then you solve for y. Let's try the perpendicular line. Again, we have the slope, we have the point. I'm going to try it the other way, which is using y equals mx plus b. We have our m right here. And then we have x, which is -7, y, which is -5. I can plug m, x, and y into this formula and solve for b. So y is -5, m is 2, x is -7, plus b. So -5 is equal to -14 plus b. Add 14 to both sides. -5 plus 14 is 9. 9 is equal to b. So then I come back up here. I now have the pieces of information I need. I have that m is 2. I have that b is 9. So I need to re-plug into my y equals mx plus b formula. That's kind of the hard part when you do it this way, is remembering to do it. Remembering to replace everything. So our slope is 2. Our y-intercept is 9. So we have y equals 2x plus 9. That is our perpendicular line that passes through the point -7, -5. All right, that's all you need to know about parallel and perpendicular lines. Hope it was informative. I will see you again in another video. Have a great day.